When you have a change of medium, you also get reflection. Anytime the medium for any kind of wave changes, it will do two things. It will reflect and it will also transmit. So what we're going to do is we're going to make some predictions for the following demos. In this demo, we are going to go from a thinner medium, a less dense spring, to a more dense spring. This is going from like a light spring to a heavier spring. Now, what I want you to do is predict what's going to happen in this case. There will be reflection, I will tell you that. My question to you is, upon reflection, will there be inversion? Will it flip over a crest into a trough, or will there be no inversion? So go ahead and make that prediction, and I'll give you a hint. Going from a light spring to a heavy spring, is that more like going to an end connected to a wall, or is that more like going to an end that's connected to nothing? Going from a light spring to a heavy spring. So this heavy spring, is that more like nothing, or is that more like a wall? Go ahead and make your prediction, and let's see what happens. I'm mainly interested in the reflection, which will happen over here. Let's check it out. So notice that it does reflect, and it inverts. Notice that on the reflection, it hits and it inverts because a heavy spring is more like hitting a wall. Now, I do want you to notice a couple of things besides the reflection here while we have this on our screen. What happens to the wave speed when it goes to the heavier spring? Notice it slows down. And that also, the slower speed, the change in medium, that's the only way you can change the speed, also changes the wavelength. Notice the wavelength is shorter here than it is over here because it's moving slower. Okay, so that is our thinner to thicker. So let's go ahead and fill that in right there. When you hitting a denser spring is it more like hitting a wall or more like hitting a free end? More like hitting a wall. So the wave inverts upon reflection. Here's the live version of this demonstration. Notice that when the pulse goes from a low density medium to a high density medium, it is inverted upon reflection. Also notice that the transmitted wave travels at a lower speed when it's going into the higher density medium, which means that it also has a lower wavelength. Similarly, let's try this, where we go to a thicker to thinner one. Now for this one, we're going from thick to thin. Ask yourself, is this more like hitting a wall or more like hitting a free end? Go ahead and ask yourself that. Make a prediction. What will happen upon reflection? And in addition, I also want you to predict what will happen to the wave speed of the transmitted wave pulse. So it's going from a thicker spring to a thinner, lighter one. What do you think would happen when it hits? Okay, make your predictions and we'll try it. Here we go. It hits, and notice it is reflected, but what doesn't it do on the reflected wave? What does the reflected wave not do over here? It doesn't invert. Let's watch that one more time. It hits, it reflects, but this end goes up and then it keeps going up, and that's why it does not invert. It does not invert upon reflection. What do you notice that's different about the transmitted wave over here? Let's watch it one more time. Here comes the wave. I'm following the wave with my arrow here. Here it comes. Dun, 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 dun. Here it goes. It hits. What is different about this transmitted wave? Watch the transmitted wave. It does move faster off to the right. So the wave speed does change because we do have a change in medium. But back to our lecture here, notice that this is more like hitting a wall or a free end. When you go from a less dense, hitting a less dense spring is more like hitting a free end. If you hit a wall, it's inverted. If you hit a free end, it's not inverted. The wave does not invert upon reflection.
In the live version, notice that the transmitted pulse has a much longer wavelength since it's moving so much faster in the less dense medium, and the reflected pulse is not inverted.
Does that make sense? Hitting a light spring, lighter than you are, is more like hitting a free end. So it does not invert. And the cool part is that light does the same thing. So rarely are we playing with rope waves, but we're playing with light a lot. What's an example of light both transmitting and reflecting when there's a change of medium? And you may have experienced this today as you walked up to your car. What do you say?
Light through a window?
Yeah, going through a window. When you look at a window in your car, you look in the window, you do see light transmitting from the inside, but you also see light reflected. So your light from your face is getting reflected at the window, coming back to you so you can see it, but it's also visible to people inside the car. It's also transmitting. So whenever light changes medium, it reflects and transmits.